Baz from the Education Hamper. Today we're running through the Sevenoaks School 11 Plus Maths paper set in January 2020. You have an hour to complete this paper with 20 questions. They get quite challenging near the end, but let's run through the paper with the work solutions. Remember to pause at each question, try and answer it yourself, and then press play, and then we can run through the solution. First thing with all these papers is that we write our name down. So in my case, that is Education Hamper. And if you do sit the exam, you would write your school down in this section here. Now, 60 marks are available in total. Marks for each question are shown in the square brackets. That's important to remember. Even though the questions near the end are quite challenging, they aren't worth any more marks than some of the easier questions. So we've got to really make sure we nail those easy questions. Right, on to question number 1. Mark's reading group has read a total of 112 books so far. The group has 7 members, including Mark. Each member has read the same number of books. How many books has each member read? So, because we're sharing the number out, it's a division. So, we're essentially dividing 112 by 7. So, let's do that. Long division. 7 into 1, you can't do. 7 into 11, that's 1. And how many 7s? That's 7. 11 minus 7. So we'll steal a 1. Again, 11 minus 7 for continuity, that's 4. Bring the 2 down. 7s into 42, that's 6. 42 gives 0. So each member has read 16 books. B. On average, each member reads 150 pages during each group meeting. What are the total number of pages read by the group during each meeting? So 150 by each member, and we know that there are 7 members, including Mark. So that's 150 by 7. 7 times 0 is 0. 7 times 5 is 35. Put the 5 here, carry the 3. 7 times 1 is 7. Add the 3 is 1000. So the answer here is 1050 pages are read per meeting. Right, on to question number 2. Jill subtracts 18 from 33 and divides this by 5. What is the number Jill obtains? So the equation's given here, but in words, so we work backwards. So Jill subtracts 18 from 33. So 33 minus 18 is the first step. 3 minus 8 you can't do, so we need to steal a 1. 13 minus 8. So 10 is 2, 5. 5. 2 minus 1 is 1. So the answer here is 15. But then she divides this by 5. And we know from our 5 times table that the answer is 3. So she obtains an answer of 3 in that question. Calculate 3 squared times 9 minus 4 divided by 3. So we've got to make sure that we do this in the correct order. So let's rewrite this so we've got all the brackets in place. 9 minus 4 divided by 3. Right, so 3 squared is 9 times 9 minus 4 is 5. Make sure we bracket that up, divided by 3. 9 times 5 is 45 divided by 3. 45 divided by 3 is 15. Answer here is 15. Question 3. Here is some flour on a weighing scale. Part A. How many grams of flour are on the weighing scale? Okay, so we need to work out what each interval means. So this is kilograms. So each of these intervals are going to be grams. So 1 kilogram, and that will be half a kilogram. Half a kilogram is 500 grams. Just write that down. So this point here is 500 grams. And how many do we need to get to this point here? So 0, 100, 200, 300, 400, 500. So each of these intervals, each interval is 100 grams. How many grams of flour on the weighing scale? So this arrow points to where this weighing scale is. So that is 1, 2, 3, 4, 400 grams. Part C, oh, it looks like part B is missing on this paper, but part C, maybe that should be B actually. Maybe they just made a mistake. How much more flour must be added to the scale to make 1.7 kilograms? Right? So each increment is 100 grams. We've said that each 100 grams. 100 grams divided by 1,000. We need to move the zero 3 times to the left. So let's just do that here. 1, 2, 3. So 100 grams is equal to 0.1 kilogram. And what do we need to do? How much more needs to be added to 1.7? So let's work out the difference. 1.7 kilograms minus 0. So it's not 0.1 here actually because it's 400 grams. So that would be 0.1 times 4, which is 0.4 kilograms. So that's how much we have here, 0.4 kilograms. So we subtract 1.7, 1.7 minus 0.4. Ignore the decimal places for now. 7 minus 4 is 3. 1 minus 0 is 1. Because we only have one decimal place, so that'll be 1.3. So the answer here is 1.3 kilograms needs to be added to the current weight to make 1.7 kilograms. Right, next question. Part 4. In each of the shapes below, make a pattern by shading with exactly part A, 2 lines of symmetry. So for this example, let's take a line of symmetry for a square, this being the diagonal. So that's one line of symmetry, and that's your second line of symmetry. But you know that it has 4 lines because you can go one through here and one through here. So we need to shade so the 2 lines of symmetry match. If we shade this entire vertical section, so no matter where you take this symmetry line from these 2 lines, it will always match the pattern. So that's the answer to that one. So let's zoom back here. So again, in each of the shapes below, make a pattern by shading with exactly 3 lines of symmetry. So 3 lines of symmetry here. I think if we take a dot in the midpoint of this, dot in the midpoint of this, and dot in the midpoint of this. So we're going to have a completely vertical line through here as a line of symmetry. And then we'll have another point going through this bit here. And another one through this vertex. Essentially giving 3 lines of symmetry. So in order to match this pattern, there's multiple reflections we need to match, and in essence we just need these 3 corners to be unshaded. So where we're going to shade is all of this hexagon. Right, that's that question. Question 5a. Round 6.275 to 2 decimal places. Okay, so the first thing we'll do is 6.275. Where there's 2 decimal places? 1, 2. Right, so this is at the halfway point. So we need to round up. Rounding 7 up is a 8, so the answer is 6.28. 6.28. B. Round 208,567 to the nearest 100. So let's write this out so we know what each of these units means. 5, 6, 7. So that is the ones. That's your tens. Here's your hundreds. There's your thousands. That's your 10,000s. And that's your 100,000s. And the question is to the nearest hundred, so we need to look at this stage here. So 567 is greater than 550, which is a midway point between 500 and 600, so we need to round up. So the answer here would be 208,600. Right. Part C, round 0.2499 to 3 decimal places. So here we have 0.2499 to 3 decimal places. Let's have a look. 1, 2, 3. So we need to round up. It looks like a double round up because we're going to round this one up and that will become a 10, and then we'll need to round this up. So the answer here is 0.250. Question 6. The total cost of Helen's pencil case, including stationery, is £6.25. How much would 12 of these pencil cases cost? So we need to multiply this by 12. So in the case of multiplying with a decimal, let's ignore the decimal for now. So it's essentially 625 multiplied by 12. So we do this, we do the units first. 5 times 2 is 10. We'll carry the 1. 2 times 2 is 4, plus the 1 is 5. 6 times 2 is 12. Now we're working the tens, so we put 0 here first. 1 times 5 is 5. 1 times 2 is 2. 1 times 6 is 6. So we add these. 0 plus 0 is 0. 5 plus 5 is 10. Carry the 1. 2 plus 2 is 4, plus the 5. 6 plus 1 is 7. So 7,500, but we have 2 decimal places already in this question, so we just shift the decimal places. So that'll be 75. So the answer here is £75. Part B. The ruler costs 75 pence. What percentage of the total cost of the pencil case is the ruler? So the first thing we can do is 75 pence is equal to 0.75 pounds. To get it the same units as the total cost of the pencil case, so that would be 0.75 over 6.25. Now we have 2 decimal places, so if we multiply by 100, we'll have whole numbers here because we're able to move this decimal place 2 places to the right. So if we multiply by 100, that gives us 75 over 625. Now we just need to work out how we're going to divide this, and I think we'll do this by long division. So 75 into 625. How many 606? How many of these 625 can go into 75? We can't do, so we need to put a dot. So we can add another 0, a decimal place. Add a 0. How many 625s in 651? And 625. Subtract it. So we need 0 minus 5. We can't do. We'll steal a 1. This becomes 4 and 10. 5. 4 minus 2 is 2. 7 minus 6 is 1. So how many 625s in 125 we can't do, so we bring down the 0. How many 625s in 1250? So 600 plus 600 is 1200, and then we have the 25 plus 25 is 50, so 2 of those. 2, and that would be 100, 1250. Subtract it, that becomes 0. So the answer here is 0.12, and as a percent, we times by 100. Gives us 12%. So of this pencil case, the ruler is 12% of the cost of the pencil case. So here we just put 12%. 7. What is the smallest number which is both a multiple of 12 and 15? So let's work out the factors of 12, which are 2 times 2 times 3. And for 15, they will be 3 times 5. And then we multiply the max number of times each multiple occurs in each number. So we have a 2 times 2 times 3 times 5. 2 times 2 is 4 times 3 times 5. 4 times 3 is 12 times 5, which is equal to 60. So smallest number, which is a multiple of 12 and 15, is 60. Question 8. Evaluate the following fractions, giving your answer in its simplest form. Show clearly you're working. Part A. 2/3 plus 4/5. So we need to know what the common multiple is for the denominator. Easiest way is to multiply this side by the denominator of this fraction by the denominator of the other fraction. So multiply by 5. And then this fraction is multiplied by the denominator of the first fraction, multiplied by 3. And you'll see that 5 times 2 is 10 over 15 plus 4 times 3 is 12 over 15, which is 10 plus 12 over 15 is equal to 22 over 15. So the answer here is 22 over 15. Next question, 3 and 2/5 minus 1 and a half. Let's convert these to improper fractions. 3 times 5 is 15 plus 2 is 17 over 5 minus 1 times 2 is 2 plus the 1 is 3 over 2. Again, we do the same thing as we did here. We cross multiply each fraction by the denominator of the other one. So this will be multiplied by 2 and this will be multiplied by 5. Let's write that a bit clearly here. Multiplied by 5. So that will be 17 times 2 is 34 over 10 minus 15 over 10. Same as 34 minus 15 over 10. So let's maybe over here. 34 minus 15. So we can't do 4 minus 5, so we steal a 1 here. So 14 minus 5 is 9. 2 minus 1 is 1, 19. That gives an answer of 19 over 10. Because we had them in a mixed number, let's do the same here. So that'll be 1, 9 tenths. That's the answer. Right. Question 9. Calculate the angles in the diagrams below. We have a circle. 2 angles are given. We need to calculate A. Total angles within the circle are 360. And to work out A, we just subtract each of these. So maybe what we'll do is we'll do 192 plus 88. 8 plus 2 is 10, carry the 1. 9 plus 8 is 17, plus 1 is 18, carry the 1. 1 plus 0 is 1, plus the other one 2. And then we subtract 280 from 360. 0 minus 0 is 0. 6 minus 8 we can't do, we steal a 1. 16 minus 8 is 8. 2 minus 2 is 0, so A is 80 degrees. Alright, part B. So total angles within a triangle are 180. That's something you just need to remember. So let's add these two up. 51 plus 37. 7 plus 1 is 8. 5 plus 3 is 8. So now we need to do 180 minus 88. Here we need a 1, so we steal 1 from here. 10 minus 8 is 2. 7 minus 8 can't do, so let's steal another 1. 17 minus 8 is 9. And there we have 0. So the answer here is 92 degrees. Question 10. Below are the ingredients needed to make 16 gingerbread men. Sam wants to make 24 gingerbread men. Work out how much of each ingredient he needs. So this is a ratio question, but we need to make more than what we have. And since we know that 24 is a multiple of 8, so if we half these ingredients first to get how much ingredients we need for 8, and then we could just multiply that number by 3 to give us an answer for 24. So let's do that for each. So for how much for 8 gingerbread men? So 180 divided by 2 is 90. So to make 8, we just divide 16 by 2. So each of these will be divided by 2. 40 divided by 2 is 20. 110 divided by 2. So 100 divided by 2 is 50. So 110 is 55. And 30 divided by 2 is 15. So let's just write this down here. That's for 8 gingerbread men. That's for 16. Now for 24, we need to multiply this by 3. So 90 times 3 is equal to 9 times 3 is 27 plus the 0, 270. 20 times 3 is 60. 55 times 3, let's do that over here. 5 times 3 is 15. 5, carry the 1. 5 times 3, 15. Carry the 1 is 16. 165. 15 times 3. 15 times 2 is 30, which means 15 times 3 is 45. So that's what we need in terms of weight for 24 gingerbread men. So 270 grams, 60 grams, 165, and 45. Even though it has the grams here, I just, for completeness, like to write it on the end as well. Question 11. Calculate x in the following equations. 17 minus x is equal to 3. So this is a rearrangement. We'll take the x to one side and put the 3 on the other side. So 17 minus 3 is equal to x. So we added x to both sides and subtracted 3 to remove it. So 14 is equal to x. So that's the answer here, 14. 3x equals 72. So we need to divide both sides by 3. 72 over 3. Let's just quickly do a long division for that. 3's into 7 are 2. 7 minus 6 is 1. Bring down the 2. How many 12's? How many 3's in 12? That's 4. And we got 0. So the answer here is 24. 5x over 4 is equal to a half. First thing we do, multiply both sides by 4. So we remove that 4 on one side. Half of, so let's just do that. So 5x is equal to 2, which is 4 divided by 2. And x is equal to, so we divide both sides by 5, 2 over 5, so 2/5. This is the answer here. What goes in the boxes to complete the calculations below? 2/5 times a missing number is equal to a third. So what we can do here is, let's divide both sides by 2/5. So we get 1. So let's put the box is equal to 1/3 divided by 2/5. And since it's a division, the way to do that is just flip the numerator and denominator over and make it multiply. So a third times 5 over 2, which is equal to 5/6. The answer here is 5/6. So missing number divided by 1 1/3 is equal to 3/5. Let's make this into a proper fraction first. divided by 1 times 3 is 3 plus 1, 4 over 3 is equal to 3/5. So here we need to multiply both sides by 4/3. To 3/5 times 4/3 equal to 12 over 15 divided by 3, which is 4/5. So the answer here is 4/5. Question 13. Calculate the area of this compound shape. 2¼ centimeters by 10. So let's do this first. We'll label this shape A, this shape B. We know this length is 10 centimeters as well. So 2¼ is 2.2. 2¼ times 10 is equal to, let's put this into an improper fraction. 2 times 4 is 8, plus the 1 is 9. 9 over 4 times 10 over 1/4. Just to write this as a fraction, 10 is the same as 10 over 1, is equal to 90 over 4, which is, okay, so let's just keep it as that for now, centimeter squared. That's shape A. Shape B is a triangle, which we can do half times base times height equals a half times 10 over 1 times the height, which is 1¼ So let's just do that. 1¼ is the same as 1 times 4 is 4 plus the 1, 5 over 4 times 5 over 4. 1 times 10 is 10 times 5 is 50. 2 times 1 is 2 times 4 is 8. So that's centimeters squared. So those are the two. So now let's do 90 over 4, which is the area of shape A. So total area is equal to A plus B. Oh, sorry, I forgot to circle the B there. Plus 50 over 8. Simplify this a little bit. Divide this top numerator and denominator by 2. So that's 45 over 2 plus, and again, we'll half this. 50 divided by 2 is 25 over 4. So now we have this. We need to have a common denominator. Multiply this side by the denominator of that, which is 4. So 45 times 4, 0, 2, 16, 17, 18, 180. So 180 over 8 plus, multiply this side by the denominator of that, which is 2. 25 times 2 is 50. 4 times 2 is 8. So now we have that. So that's equal to 180 plus 50 is same as 18 plus 5, which is 23. So it's 230 over 8. Let's do this long division over here. Over 8. 8 into 2 can't do. 8 into 23 is 2. So that gives 16. 13 minus 6 is 9. Bring the 0 down. 8's in 90 are this long division over here, 230 into 8. 8 into 2 you can't do, 8 into 23, so that'll be 2, 16 minus, so 3 minus 6 you can't do, steal the 1. 30 minus 6 is 7, 1 minus 1 is 0, bring the 0 down. 8's into 70, that'll be 8, giving 64. Again, can't do 0 minus 4, so we steal a 1. 10 minus 4 is 6. And we don't have any zeros, so we need to put a decimal place here and bring in a 0. 8's into 60 is 7, which gives us 56. Again, 0 minus 6 we can't do. Steal the 1. 10. And that 10 minus 6 is 4. Add another 0. 40 divided by 8 is 5. Should clear that. Yep, 0. So the answer here is 28.75 centimeters squared, which in essence is 28¾ centimeter squared. Next question. 14. Fill in the missing numbers of the following sequences: 3, 5, 7. Missing numbers 13 and 15. What's the difference between 3 and 5 is 2. 5 plus 2 is 7. 13 plus 5 is 15. So 7 plus 5 is 9. 7 plus 2 is 9. 9 plus 2 is 11. 11 plus 2 is 13. So that's your answer, 9 and 11. Part B, minus 33, minus 6, 21, 102 and 129. So what is the difference? Okay, so to work out the difference here, you subtract negative number from positive. So that's 21 minus 6. Two minuses become a plus, so 21 plus 6 is equal to 27. So the difference here is 27, and I imagine that the difference here will probably be 27. Let's check that. 129 over 102. 9 minus 2 is 7. 2 minus 0 is 2. 1 minus 1 is 0. So yeah, 27. So the difference here is 27. 21 plus 27. 7 plus 1 is 8. 2 plus 2 is 4. So that's 48. And then we have to do the same. 48 plus 27. 8 plus 7 is 15. Carry the 1. 4 plus 2 is 6. 7. 75. So that's 75. Right. Question C, sorry. 10, 11, 15, and spaces 65 and 101. So the difference here, if we look at this, there is 1. Difference here is 4. So what can we do here? So if we do 1 squared, which is 1, and this will be 2 squared, which is 4. So this one I imagine is 3 squared, which makes 9. So let's try that. So 15 plus 9 is equal to 24. Okay, so if we make that 24, which means we're going 1 squared, 2 squared, 3 squared, so this one's probably 4 squared, which is 16. So 24 plus 16, 6 plus 4 is 10. Carry the 1. 2 plus 1 is 3, 4, 40. 40, and this one will be 5 squared, 25. 40 plus 25 is 65. 6 squared is 36. So 65 plus 36, just to check. 5 plus 6 is 11. 6 plus 3 is 9, 10, 101. Yeah, so that's it. We were looking at the squares here. Right. Question 15. Below is a coordinate grid including a point A labeled below. Part A, give the coordinates of the point A. So here we have A. So coordinates, we read the x first, minus 1, and then it goes up 1, 2, 2. So that's your coordinates of A. Mark the coordinate minus 4, 3, and label this point B. So we have to go minus 4, 1, 2, 3, 4, and go up 3, 1, 2, 3. So that there will be point B. The point C is obtained by reflecting the point A in the x-axis followed by reflection on the y-axis. Give the coordinates of point C. Okay, so we need to reflect along the x first. So we're 2 up here. If we reflect, we'll be at this point here, minus 2. So let's call this A prime. And then we reflect along the y, which is 1 space to the right. So that'll be here, C. So the coordinate of point C is 1, minus 2. 1, minus 2. Okay. 16. One clock gains 5 minutes every hour, and another clock loses 10 minutes every hour. After 1 week, how many hours will the slow clock have lost to the fast clock. Okay, so there's a number of things here. Um, so we're looking at how much time over the course of a week. So I think the first thing we'll do is how many hours in a week. So there's 24 hours in a day, and there's 7 days in the week. So multiply those two numbers. 7 times 4 is 28. 7 times 2 is 14, plus the 2 is 16. So 168 hours in a week. So first thing we need to know is that let's do the fast clock. Label that clock A. 1 hour gains 5 minutes every hour. So if there's 168 hours in the week, it will gain every hour 5. So we need to multiply that by 5. 8 times 5 is 40. 6 times 5 is 30, plus the 4, which is 34. 5 times 1 is 5, plus the 3 is 8. 840 hours gained. B. Every hour that clock loses 10 minutes. So in a week there are 168 hours multiplied by 10 minutes every hour. That gives us 1680 minutes. Sorry, going back here, that's not hours. Made a mistake here, that's minutes. Because we're multiplying by minutes. So the difference between these two, so 1680 minus 840, that will give us the difference in time in minutes. 0 minus 0 is 0, 8 minus 4 is 4, 6 minus 8 we can't do, make that 0, that'll be 8. 840 minutes. That's how much the slow clock has lost to the fast clock, but we need to put it in hours, how many hours. So there's one more step here. So we need to do a division here, 24 into 840. And in this case, 24 into 84 is 3, 72. 4 minus 2 is 2, 8 minus 7 is 1. Bring the 0 down, 120. And then that will be 5. 24 times 5 is 120. That gives us 0. So therefore it will have lost 35 hours. A. The volume of the cuboid below is 64 centimeters cubed. Calculate the value of the unknown length x. Right, so the volume of a cuboid is the length times the width times the height. So that'll be 2 times 4 times x is equal to 64. 8x is equal to 64. Divide both sides by 8 to just have x on one side, and that is equal to 8. So the answer here is 8 centimeter cubed. B. A cube has the same volume as the cuboid above. So the first thing we know is that it's a cube, so all three lengths are the same. Let's just draw it. So x, x, and x are all the same, and the total volume is 64. So we can write an equation that x times x times x is equal to 64, and that is equal to x cubed is equal to 64. The cube root of 64 is 4 times 4 times 4. So the cube root of 64 is 4. Let's write that down. So we know it's a cube. A cube has 6 faces. Each face has a surface area of 4 times 4. So remember x times x. So we've already worked out that x is 4. So 4 times 4, 16 centimeters squared. So we're doing surface area, not volumes. We're now in the squared space. Now there's 6 faces, so we have to multiply that by 6. 16 times 6. 6 times 6 is 36. Carry the 3. 6 times 1 is 6 plus the 9, 96. So the volume here, sorry, let's be clear, I made a mistake there. The surface area here is 96 centimeters squared. So I imagine you get a mark for making sure that you write the correct unit down because we've been using volume and lengths and surface areas. The diagram shows a design formed by drawing 6 lines in a regular hexagon. The lines divide each edge of the hexagon into 3 equal parts. What fraction of the hexagon is shaded? You must show relevant working to obtain marks. Okay, so we have a hexagon here. It's split into various parts. What we can do here first is that the lines divide each edge of the hexagon into 3 equal parts. So I think the first thing is that these triangles form a hexagon when combined. So let's draw that. And they're all into equal parts. So I think we can do the same for all of these. Just give another example of it. Right, so each big hexagon has 6 smaller hexagons, right? So we have each larger hexagon has 6 smaller triangles, sorry. And how much of these large hexagons do we have? So we have 1, 2, 3, 4, 5, 6, 7. So that's how many smaller triangles we have. But then we have these small triangles. How many of these do we have? 1, 2, 3, 4, 5, 6. So that's 6 plus these that form a star. 1, 2, 3, 4, 5, 6. 6, which is equal to 42 plus 6 plus 6, which gives us 42, 48, 54. Right, 54. That's your total amount of area. And how much of this is shaded? So we have 1, 2, 3, 4, 5, 6. And then we have 6 triangles that form this shaded hexagon. That's 12. So the total area is 12 over 54 that's shaded. Now here we can divide by 6. So that gives us 2. 6 into 54 is 9. So the answer here is 2/9. Let's write the answer here. Area shaded is 2/9. 18. A lot of words here, but let's read through it slowly. The standard Fibonacci sequence 1, 1, 2, 3, 5, 8, 13 begins with 2 ones, and each later number in the sequence is the sum of the previous 2 numbers. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5. Other Fibonacci-like sequences can be constructed by starting with any 2 numbers, a and b, not necessarily 1 and 1, and using the same rule for creating the other numbers in the sequence. What is the first term of the Fibonacci-like sequence whose second term is 4 and whose fifth term is 22? So 1, 2, 3, 4, 5. So this sequence isn't that. So let's work from number 2. Number 2 being the first term. So we've tried it with number 1. It doesn't. The fifth number is not 22. So if we start with 2 as the first sequence, and then 4, 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 6 is 16, 1, 2, 3, 4, 5. So it's not that one. So let's start with the first term as 3, 6, 3, 4, sorry, 4. Let's start with the first term as 3, and we already know that the second term has to be 4. So 3 plus 4 is 7, 7 plus 4 is 11, 11 plus 7 is 18. 1, 2, 3, 4, 5. So that's not it. So let's put a cross there and cross there. Next term, let's start with number 4. Second term is 4. Third term is 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 8 is 20. 1, 2, 3, 4, 5. Okay, so it's not that one either. Next term, start with a 5, then a 4. 5 plus 4 is 9. 9 plus 4 is 13. 13 plus 9 is 22. So 1, 2, 3, 4, 5. So that's the correct answer. So what is the first term in the Fibonacci sequence? So it's number 5. 5 is the first term in the Fibonacci sequence to give the fifth term of 22. Question number 20. A rectangle is made by placing together three smaller rectangles, P, Q, and R, without gaps or overlaps. Rectangle P measures 3 centimeters by 8 centimeters, and rectangle Q measures 2 by 5 centimeters. Give all the possible measurements of R, which R being a rectangle. So let's try and draw out the different types of rectangles that we have. So first shape that we could have is rectangle P, measures 3 by 8, and then rectangle Q is 2 by 5. So, so we go up here, as being 5, 2 centimeters probably here. So that's 5 and 2, and that gives rectangle Q. So rectangle R, because all three form a larger rectangle, just choose another color here. Rectangle R would be here, and that would be 5 by, so 8 minus 2 is 6, so 5 by 6. So let me go back to that color. So number 2, next shape we can have is 3 by 8. 3 by 8, and that's P, and then we can add 2 by 5 here. So that's 2 and 5, and that is Q. Let's go back to the blue. And then this is R, which will be 5, so that'd be 2 by 8. Right. So that's the second option. Third option of a shape here, right, could be 3 by 8, and then this one, hold on, we'll do here. So that would be 2 by 5, which would be Q, and then we would have R. Hold on, I've done this. Okay, so let's call this R, and that one would be 5 by 1. Labeled this incorrect. This in fact is P. Oh, P. And I think we have one more option of drawing this shape. So we can have a 3 by 8 P. Then we can have a 2 by 5. So 2 by 5 as Q. Then here we have 3, because 5 plus 3 is 8, by 2 as another shape. So I think those are the 4 types of rectangle that we can make using all 3 of these shapes. Let me just label this R. All the measurements for R are either shape 1, 6 by 5 centimeters, shape 2, 8 by 2 centimeters, shape 3, 5 by 1, shape 4, which is 3 by 2 centimeters. Folks, that concludes this paper. 20 questions. Near the end, quite difficult. Quite wordy questions, so really need to decipher what the maths is, but really understand the question. But as with other papers, the last few questions are longer, but they aren't worth that many more marks. So really work your way through methodically, get all the easy marks, and work your way through to the end. I'll see you next time. Really appreciate you spending the time working through this paper with me, and I hope you have a great day. Thank you. Bye.